So the title of the panel is Water Energy Nexus. But if you were to ask most water companies, they would tell you it's much bigger than a nexus. It's an interdependency. You can't have water without talking about electricity. You can't have electricity without talking about water. So water and energy are critical, mutually interdependent resources. The production of energy resources requires large volumes of water, and water utility service requires tremendous amounts of energy. The companies, all of us, are seizing the win-win opportunities. We are finding collaboration amongst our industries to benefit our consumers, whether you're talking about the municipal water company or the privately held water company. I want to give credit to the man who said this. I have not checked his resource or his stats, but I believe it to be true when I consider the source. Jim Jenkins with American Water. As you all know, Susan Story is the CEO of American Water, started her career in the energy industry. They say if every water utility improved their water pump motor efficiency from the existing average of 55% to the optimal efficiency of 80%, it would save enough electricity to light up Chicago for 2 years. So, something to think about. Several organizations, including American Water, as well as the National Association of Water Companies and the American Water Works Association, have submitted letters to the EPA, as you all know. I'm sure you've already discussed, certainly we'll be discussing it here, to encourage water energy efficiency measures as part of the state energy efficiency plans that ultimately may or may not be adopted by the EPA. All utilities benefit from energy savings, greater efficiencies, and updated regulatory mechanisms. States benefit from a facilitation of better, more affordable, and more reliable utility service. So let's talk about that regulatory impact. Our panelists today are from OUC and JEA, two wonderful municipals. Florida is blessed with municipal electric providers and municipal water providers. But if you were to talk to the private water companies that are regulated by the Public Service Commission, they would say to you on this issue that the rate of return model of regulation doesn't do a whole lot to incent collaboration in the water energy nexus. That's what they would say. Use of alternative mechanisms will encourage water energy nexus benefits that lower energy usage, lower the industry's carbon footprint, reduce cost of water for consumers, and drive innovation. It was so important to the regulatory conversation, the last 5 years in particular, that in 2014, the National Association of Regulatory Utility Commissioners, NARUC, adopted a resolution that's still on the books today. I want to read parts of this resolution to you as a way of introducing our speakers. It was adopted in 2014. Whereas the water energy nexus describes a close relationship between two critically important sectors of the economy, and whereas today's energy extraction and electricity production requires a tremendous amount of water, and whereas the treatment and delivery of water and wastewater services requires a significant amount of energy, representing about 4% of all U.S. energy consumption each year, a share that could rise significantly as a result of antiquated and inefficient nature of U.S. water and wastewater infrastructure, as evaluated by the American Society of Civil Engineers. Whereas efforts by water utilities to enhance efficiency by replacing outdated water pumps, integrating smart information and communication technologies to identify leaks in real time and streamline other processes, and using a greater share of alternative energy to fuel operations, among other initiatives, have already yielded measurable reductions in the amount of energy used in water and wastewater services. Whereas states possess many of the tools needed to implement policies, programs, and incentives to fully employ the water energy nexus for the purposes of enhancing energy efficiency efforts that could also yield more reliable service, stable rates for consumers, and lower carbon emissions for states. Be it resolved that NARUC convened at its annual meeting in San Francisco, California in 2014, urges states working with appropriate federal authorities to proactively explore the water energy nexus and pursue regulatory reforms that might be needed to unlock further progress toward enhanced water and energy efficiency. I don't pass judgment on whether these policies are correct. I don't even know if this room agrees with them or not, but it is absolutely true that that's the national conversation that's occurring as we sit here today. So this panel, two very, very experienced people, OUC, the reliable one, host of Chip Merriam. Many of you know Chip. He's been in the industry for a very long time and is a wealth of information on this subject. Mr. Merriam is responsible for managing energy and water regulatory and compliance matters for OUC and is heavily involved in the discussions that I just described. Paul Steinbrecher, the Director of Environmental Permitting for JEA. I remember, just to show everyone exactly how old I am, Paul, I remember when JEA was Jacksonville Electric Authority and United Water got out of the water business in Jacksonville, allowing Jacksonville Electric Authority to be rebranded as JEA. He has responsibilities for overseeing JEA's full range of environmental permits. Prior to joining JEA, Paul was the process engineer and program manager for CH2M Hill. Please help me welcome each of them, and then we'll talk about the format in just a minute. So the format that's been selected for this panel is we're going to give them each a few minutes to speak, and then we will open up the floor for questions. I do encourage you to write. I understand that there are question cards at the table. I always like to tell folks, this is what you make it. This is an opportunity to ask those questions. There are no dumb questions, and I'd much rather hear your questions than mine, so I hope you take us up on that offer. Which one of you would like to start? Go, Chip.
So thanks very much, Lila, and she actually did a wonderful job of introducing the actual discussion of the Nexus, so thank you very much. But actually, what I'd like to do today is do a couple shameless plugs. First off, I thank Nestle very much for their product up on the table, but on your tables is water from our service territory that we actually call H2OUC, so enjoy the iced water that's there. It's very good. Secondly, I want to pick up on a few things that were introduced. Our industry, the energy industry, sat around for many years, decades, and watched the regulations that were being, frankly, or were changing and impacting the consumptive use side, and really just kind of sat back and said, God, it really stinks to be you guys. But we had a water side ourselves, but it was a small portion of our revenue source, and our energy guys never quite understood the impact of all the regulations that were coming through on the water side. Then as administrations changed, we started to learn what that is. And as Lila described, there was some, as soon as my slides come up, there were some impacts that we can look at, and there's some very visual things that we have in place. Pick out where you live and look out where your local providers are. I know Mike Soul can look at his boundaries. I can look at mine. JEA can see theirs. But energy is not something that is done 20% of the time during the day. It's a 24-hour day, 7-day a week, and it is a culture that we live in. And here's the premise of it, again, from the introduction. We are owned by our ratepayers. Our job is to make sure the rates that you pay are the lowest they can possibly be. And further, we're running a business that is going to incentivize you. We're going to sell you a product, and we're going to incentivize you every single time we can to use less of it, whether it's in the water side or the energy side. So you better be ready to walk the walk in this business process, otherwise you're going to be really upside down quickly. What it has done for us is that we've actually looked within to make sure that everything we do is not building new infrastructure unless it absolutely has to. And the infrastructure we build will last 50 years. Our difficulty is that we have a federal agency that's making rules so fast that our 50-year infrastructure is starting to look more like 10 and 15-year infrastructure with 30-year money borrowed against it. And that lovely agency would be called the EPA. We also have a race, as was discussed, to reduce the carbon footprint in the United States. The interesting part of this is that it's actually been happening anyway. As the infrastructure got older and as the prices for fuel started to change around, many of us diversified differently. So the carbon output that was part of the United States has been steadily coming down. We go forward and now sign an agreement in Paris that we're competing internationally against manufacturing in China and some other countries. And today, I think China's almost going commercial with every 9 days with a new coal plant. And our coal plants are now becoming more and more obsolete, not because they are, but because of federal regulations that are driving us into a place. The reason that it's going to be uncomfortable, the reason I bring it up is that's going to impact everybody's bottom line. If I buy a car and I drive the car, and then the Department of Motor Vehicles comes up and says, not only are we going to tell you that car is obsolete, you still have to pay for it, you can't sell it, you can't drive it. That's kind of the model we're looking at right now. We're going to be owning these $500 million projects out there that aren't going to reach maturity in 40 years or longer. For us, again, to be kind of parochial, we bond for 30 years on our projects with hopes to last for 50 for our ratepayers' benefits. We then look at the model we're going after, and the model is going to be moving things down in a fairly rapid pace. And why that becomes important is if we are all in the same business, we're all trying to achieve the same goals, when the time comes to build these more efficient, newer plants, it's going to be very difficult if we're all going after that build at the same time. A part of the industry's argument with the agencies was, we've got this. Let us come up with a plan, and we're going to use a term called the born-on date, made famous by Budweiser. And the born-on date is going to be whatever the nameplate date is, give us 40 years, and we'll phase them out on our own. But that's not an option we got. And again, the reason is this will directly impact some of the biggest users that buy our energy, buy FPLs, buy Southern Gulf Power's energy, which are the utilities, unless it's Universal. Universal is our biggest customer, besides ourselves. So to give you an idea what we're faced with right now, and again, like I said, it was a difficult thing to sit back, and I was a regulator for a while looking at all the regulations that are going on, to come into energy, and then to see this. And this is the amount of regulations that have been written through the administration process since 2011. This isn't a history of it. This is just since 2011. You know, you're looking at 5 years of administrative exercise that's actually created all the new rules we have to follow through. And to give you an idea, the doors in this is actually in a congressman's office, and those doors are larger than 7 feet, and there's 7 piles of those documents there. And not only are there many of them, but you know, it's the way one interrelates with the other is a math problem that many engineers can't figure out. You've got clean water requirements you've got to go through. You've got clean air requirements you've got to go through. You've got the requirements of the state you have to go through, and then the PSC and other regulatory bodies that are there. And again, we're trying to do everything we can to keep the prices down as low as we can. And I think in today's world, most of us are very competitive, and that's on purpose. We're doing everything we can to get there. But going back to walking the walk, what I want to talk about is when you're in this business and when you have to provide an example of doing it correctly, you better be real introspective in the process. And I believe we've done this. And there's really no way for me to do this fairly, I don't think. But OUC uses absolutely zero potable water for the generation of energy. All the water that comes in for our cooling water and to make steam in order to turn the turbine is in a partnership with Orange County. In a very large pond you'll see to the right, that's kind of like a backward L, that is how we store many days of water. We actually bring it in from their system, we pile it up in there, we pull it through, and then we have 2 hyperbolic chambers that sit here, and there was a discussion about how expensive things are. Each one of those is over $50 million to buy, but there's a good reason for it. Every drop of water that comes in, again, this is reuse. We've talked about disposal, how to use it, how to efficiently use it. Every drop of water that comes in that system will go through our power plant 9 times before it's evaporated out. Now, this is water that was originally, not that long ago, disposed of. and it comes in, we run it through our system, we purify it, we take the use of this very seriously, and we actually, when you go by our system and you look up at our power plant, you'll see two things. You'll see, clouds coming out of our power plant stacks, you'll see clouds coming out of our natural gas combined cycle turbines, and you'll see steam coming out of our 2 hyperbolic chambers. But here's what else we did. We knew we needed water in order to provide the greatest efficiency of water quality. Again, Drew was just up here and others talking about the importance of surface water discharge. In the system, everything is captured in ponds that you see here, here, and here, in lined ponds that's actually utilized. It goes through a brine concentrator, reverse osmosis, if you will. It is then piped through a system as deionized water into our hydric scrubbers, and we're 99% scrubbed of SO2, SO3. We don't have an outfall in this site for stormwater. All the stormwater that falls on the industrial site goes into one of those lined ponds, is captured, and then is actually released through the smokestacks. So, kind of the moral to the story is we get the nexus. We get the importance of what water is and how it is, and we've got to be committed to that as our partners are in the industry. This is something we talk about all the time, not just your bills and how that impact is, especially with the volume, but how do we make sure that when you get introspective or you look at us from the outside, can we stand up and say, we're not making you do something we didn't do ourselves first? On the other side, on our consumption side, we've actually had kind of a unique process as we've gone through our growth with water conservation. Over time, we've had a significant amount of change, and again, we're incentivizing you to buy a product from it and use less of it all the time. And we've actually brought the numbers down significantly, that up until a year ago, we were probably using the same amount of water that we were using in 1995, and we've added over 43,000 new meters. And a meter in our business isn't necessarily a new house. It could be a new building, it could be a new business or industry. Additionally, we have to measure how we do this and how we make sure that our residents understand the educational process, our ratepayers and customers. And what we're finding on both sides of the new businesses coming to Florida, there's several things they're demanding of us. One is they want their water and their energy as inexpensive as possible, as reliable as possible. I'm going to talk about energy reliability in a second. But more importantly, that it is more than just turn the switch on and it happens. When they turn the switch on, it can never go off. When they turn the faucet on, it can't lose pressure. The new businesses coming in that are loving Florida at this point in time because of our system are loving it because go back not too long ago, if you didn't have a 12-year-old in a house, you couldn't keep the 12 o'clock from flashing on your VCR. Several engineers that used to work for us used to put black electrical tape over that so they didn't have to worry about it. Today, a momentary outage, which is just a bump, a squirrel, a frog, or something going across a transformer very quickly, not making it all the way across, admittedly, but going across very quickly, would actually cause the new computers in rides here at Universal, in factories that are making the bottles of water, the plugs for this. They cannot stand that kind of energy interruption. So our goals today are not system outages or transformers failing. It is how many thousandths of a second can we get it down to so there are no interruptions in that system. On our water quality side, what do they have to do in order to make sure the water they use from our system is clean enough, they don't have to add additional treatment to it, and is it available all the time that they need it? So those are challenges. And again, this is a slide that actually demonstrates how you can grow meters and reduce the overall demand on the groundwater system as we have. Some of this is due, again, because of our partnership with both the City of Orlando as well as Orange County and the reuse that we use in the system. But as was said earlier on the agricultural side, you've got to deal with rainfall. And as we look at this process, we have to marry up what the rainfall impacts are with our consumption. And now we get into talking about, we're going to rate you, we're going to match you, we're going to look at you through your per capita numbers. Well, what year are you going to match this? How are you going to count it? Who are you going to count it? And what are you really looking for? So we need to learn to do a language that we can all speak. And our industry's changing. One of the things that I described just a second ago was how the momentary outages are becoming so important. We're also getting a lot of new inventions that are coming in, including, you've heard about, batteries are coming, new cars are coming, wind energy, solar, so forth and so on. But that's yesterday's news. That's yesterday's issue. The energy customer of tomorrow and today. Could you imagine, I joked at one point when the Jetsons were out, I couldn't wait until I got to be in a position where I would actually be able to drive one of the Jetsons cars or get my own backpack and fly around the neighborhood. Well, then we started getting into iPhones and other things that actually allowed you to do things that were much different than before. What if you could control your energy consumption, you could sell energy, you could deal with all the things that you could store energy, you could create energy using solar on your own site, and you could sell it to your neighbor. Well, while that is something that appears to be in the future, we're dealing with that today. We're looking at energy providers that are now creating their own distributed generation systems that are going to be part of their overall planning as they move forward. It's being done by large organizations, airports, others, where we become some of the backfilling of that. Their conservation practices are growing. Their demands on our load are getting smaller. But it is very possible, and there probably are several homes today that have become so efficient while they can't get off the grid. There's not enough battery storage, and there's not enough combinations. It's not just one battery. It's a series of batteries and a series of different kinds of batteries to meet the needs. It is well within our reach in the next handful of years that this scenario where somebody's actually managing their energy cost and they're putting it on the grid that we have to distribute and balance in order to sell it to somebody else has to come together. So what we're wrestling with now more than anything else is, are the dynamics of regulation even able to keep up with the current change in our industry and the water industry? And I'm going to tell you it's not. We're chasing sometimes regulations in Washington that are talking about things that happened 5 years ago. And they're regulating something that we don't do anymore. And that's actually a real statement. We're actually chasing that. And I'm going to give some props or support out to DEP. They've changed their relationship with us so significantly that it's allowed us to take solar panels and put it on top of a landfill in our system, our coal ash landfill, so we can add additional diversity in our system, another 13 megawatts of solar. And we could have gone through an entire siting process and have to put that up and make things happen in a very complex, long 6-month to a year process. They did it in 9 days through an ERP modification that we would pick up later on in our next site modification, and we would clean up those things in that path. That kind of creativity in this type of system, especially with all the other things that are changing, is spectacular. So my hat's off to the department for being there. Again, the new energy company is going to be different. We're still going to try every chance we can get to drive your bills down. That's the only marching orders we have. We know that it's dependent on fuel. You know it's dependent on fuel when you go to the pumps. Different gas, but similar situation. As long as prices stay down, we'll continue to be creative, use less fuel, and do it in a way that would probably surprise you. In our coal plant, as I said, we evaporate a lot of stormwater. We also pull landfill gas in from the Orange County landfill that's right next to us. We run it through our system and clean it up and pipe it directly into our boiler. We keep 40 days of solid fuel, coal, on the ground in that site so that we can go in and out of fuel changes when the prices go up or down. Lila described some of the concerns about the pipelines coming into Florida. NextEra, Florida Power and Light, and Duke are currently working together to put a third pipeline in. We were constrained this summer, but because of fuel diversity, we were able to put coal on and backfill those areas that were not able to meet the demands. So there is a lot of creativity, there is a lot of thought. We will remain competitive, but we're not going to be in the future the same baseload generation you grew up with. Our system is going to go in multi-directions. We're going to buy energy from people we may have never done before. We're going to provide energy to people in a different way than we ever have before. And we will probably use even less water. As we've shifted from some of our oil plants to coal plants to natural gas plants, we've actually seen the volumes of water cut down. If I compare it to an old technology which we have in Indian River, once through cooling power plant was using 823 million gallons a day of water. 10% of that evaporated. Easy math to do. Now go to a modern-day coal plant that sits in the center of the state that has no access to that water, that runs off of 14 million gallons a day of reuse water and uses it till it goes through the system 9 times. That's where the Nexus comes together and where the creativity becomes real. So I'm going to stop there and let Paul have some discussion, because he's going to get a little bit further into the weeds. I hope that 2 things have come out of this. One, you understand that the power generation is a lot different than you might have thought about how we deal with stuff and what's going on. And secondly, we hope you all catch up with us and you start looking at things that will modernize the energy use in your house so we can charge you less to use less of our product. Thank you.
Good afternoon. Paul Steinbrecher. It's good to be here with you today. I'm going to introduce you first just a little bit about JA for those who may not be familiar with us. JA is the regional electric, water, sewer, and as you'll see up here, chilled water provider to downtown buildings, the stadium, things like that in our community. We serve Duval County and parts of 3 surrounding counties in Northeast Florida. On the electric side, we're the 7th largest municipal electric provider in the United States. On the water sewer side, we're the 2nd largest in the state of Florida providing those services. I think in our industry in the state of Florida, we have a reputation of being an efficiently run business. And I say that especially in this audience because I think people here really appreciate that. The energy water nexus, you know, that's kind of a loose term. It can mean different things to different people. Today, I'm going to talk to you about that, about what that means within a utility, an integrated utility that makes those services, provides them to you, and also provides them to ourselves. I think, as Lila said, it's easy to see that water production and water transportation take a lot of power. Some of our power production techniques take water, not all of them, but I'm going to try to tell you how a regional utility is focused on sustainably, environmentally providing those types of services while also being a sustainable business operating unit on our side and providing low rates to you. I'm going to talk to you in those 3 different buckets, the 2 sides of our business, the energy side, the water side, and then a little bit about how we drive conservation. First, on the energy side, we really recognize the need for a diverse energy portfolio from lots of different sources. As a major energy provider, JA learned this lesson way back in the 1970s. We were long on oil at that point when the oil crisis hit in the 1970s, and it created a lot of problems in our community and attracting businesses after that. We remedied that by the late 70s and became much more energy diverse in how we provide it. And you can see some of the ways that we do that up here. We have solid and liquid fuels, natural gas, a growing amount of renewables, and I would count conservation in there as well. Gas is the new oil a little bit, right? Who would have thought 5 or 6 years ago that we'd see the kind of gas supply that we see now? We're all beginning to wonder what's going to happen with fracking regs. What's that? What does that have potential to do to gas supply in the future? I'll remind us in this room, as recently as 2004, we had hurricanes that crisscrossed Florida. We live on a peninsula. We have to import these fuel sources into the state, and we had interruption of the power supply from that. So I bring that to this group's perspective because I think AIF is well situated to understand the need for a diverse number of fuel resources as we move forward. There will not be a quiz on this slide, don't worry, we're not going to go into that process. But we've been an innovator in clean energy. One of those solid fuel plants that was on the top left on the previous slide, shown on the top left here again, this is our continuous fluidized bed boiler process at north side. If you're in Jacksonville and you're near the Dames Point Bridge, you're looking at one of these units. This was and is a groundbreaking Department of Energy clean coal technology project. It produced and produces today 2.5 times the power of the units that it replaced for 10% less air emissions. Pretty astounding, right? If you look at the small top right picture, the clean stack on the far left, that's the stack from these units. You can never see any emissions whatever from it. It's that clean. In this room, I bring it to your attention because it's mostly a dry process. It doesn't use very much water, and there's very little water that comes out of it. It has capability to burn a whole range of solid fuels: coal, petroleum, coke, biomass. And this is a good example of the type of a plant we hope to continue running well into the future, even as we move into a carbon-constrained future, because there's just too many good things about it, and there's trade-offs to be made on any of these processes. We're also focused on preserving the aquifer by continuing reclaimed expansion wherever that's feasible. This slide shows a couple examples of how we use reclaimed water at our 2 largest power plants, at a variety of our power plants, actually. I'm going to start on the map on the right. The scale of that is quite large, by the way. You're looking at parts of 3 counties there. If you look at the circle on the top, those are our 2 largest power plants. Those plants get reclaimed water from a wastewater plant about 5 miles to the west. That's where that purple line's going. And at this point, they take virtually all of the water from that wastewater plant and use it for process purposes and to augment the water in the cooling tower that you see there. If you look about, I'm going to guess it's close to 20 miles south of there, that's called our south grid, and that other little dot that's shown down there is our Greenland Energy Center. That's a gas plant right now. It's a single cycle plant. It doesn't need any cooling water. As the community grows down there, it was sited in that region partially to put it alongside the very large reclaimed water system that we have in that area of town. We connect 4 of our wastewater plants. It's one of the largest interconnected systems in the state of Florida. And in the future, when that turns into a combined cycle plant and does need water, all the water resources of that plant will be provided by that system. We've had other speakers that have talked previously about how location really matters on making these cost effective. Sometimes we get the choice on where to place one of them or the other, and that helps make it much more cost efficient. We are also beginning to look at, we do have some remaining available reclaimed water. It tends to be on the west side of the river in Jacksonville, in older, more built-out areas of town where you see the skyscrapers and things like that when you drive through town. We are beginning to look at reclaimed water, as others have mentioned earlier today in here, as a potential future source of drinking water. It doesn't make sense in that area to pipe it long distances. There aren't irrigation demands there. There aren't industrial demands nearby that need it. So we're going to look at that as an emerging technology. Which brings us to this. You've heard others in here say today, potable reuse is coming closer in Florida. It's an emerging technology, but not from a we don't know how to do it standpoint. They're drinking it on the space shuttle today. That's how they get their water. We have the technologies to do it. It's a matter of economics. It's been an expensive and continues to be an expensive and energy-intensive process to do this, and it's a public perception issue. So people are working now on cracking those things and moving it forward. We're beginning a 2-year research and development project this year. I think Ryan and others on a previous panel did a good job of talking about, on the 2 pie charts on the bottom, I'm just trying to show what they were talking about. We think it'll add some other increment of water resource in the state of Florida that we don't have right now. How much, I think, is anybody's guess in the future, but that's what I'm trying to connote with the yellow sliver there, that it adds yet another potential water resource in the state of Florida. I'll tell you, next year, with Tom Feeney and Doug's and a few others blessing, we may be in a position with our pilot. Maybe I'll have some of this produced from a pilot plant, and I'll bring it here so some of you can try it out for yourself next year. I've sort of switched to the wastewater side here. As Chuck alluded to, some of our own processes can be some of our largest energy consumers. In Jacksonville, there's a steel plant that's the largest energy consumer. On the water side, it's the school board that's our largest water user. On the wastewater, when we treat wastewater, the biggest energy demand is from giving oxygen to the bacteria that actually remove the pollutants from the wastewater for us and remove the nutrients from the water so that it can be safely returned either back to the environment or as a water resource. We've worked hard on that. We've replaced those, just as Lila was pointing out, we've replaced those kind of mechanical processes so that we ourselves, we charge both sides of the business. The electric charges water and vice versa, and have reduced those demands by about 30% by doing that. We're also capturing energy from wastewater treatment. So people had lunch before they came here. Sometime today you're going to use the bathroom. That stuff ends up in tanks over there like you're seeing on the left side, the solid materials that come from all of us. In those tanks, those are called digesters, and we convert your wastes ultimately to water and methane gas, and that's what you're seeing stored in the tank that has the bubble top on it. That's a gas storage tank. And then we take that gas and we use it to generate heat for those digesters and to produce electricity to partially offset the electric demands at those wastewater treatment plants that you're looking at right there. People in here understand for any of these techniques, there's no free lunch. Every one of these efforts takes time, money, sometimes it takes additional power. I'll give a couple quick examples like that right before I close. On the left, those are ultraviolet disinfection lights. We replaced our chlorine disinfection at our wastewater plants because it gave really quite a number of water quality and safety benefits to the community. It did it at the cost of very high electric usage. That's a trade-off that sometimes occur. And there's that reclaimed water system again. Many, many benefits from it. But they are, at the end of the day, they are energy-intensive systems. We're taking your wastewater, bringing it to, in that case, 4, 5, 6 different wastewater treatment plants, pumping it to those, treating it to very high levels with energy-intensive processes, and then pumping it back the other direction. And location matters there. Location matters a lot. In our own case, if you look at that lower gridded system, we're wheeling water 26 miles from the northern end, where there's a lot of supply but not much demand, to that very bottom end where you see all the pipes spreading out. That's where the new houses are going in our community, so we're pushing the water out there. But a couple examples to help bring some of this down to earth for you. Of course, we're in an unusual business. Everybody in here is in business. We're in a business that actually helps, we ask our customers and we help them to use less of our own product, right? That's a difficult proposition. Very easy to see why we would do that and the benefits from a energy water nexus standpoint. Easy to see that. Some of the techniques include emerging technologies like smart meters on the left, on the water and electric side, that allow our customers, for example, to go online at any time and see what their usage is, set alerts and limits, or actually shut the thing off, and help them use our services more wisely and reduce their usage. All utilities have a variety of programs, us included, for water and energy audits, numerous education campaigns, and we do numerous incentive programs on electric vehicles, charging stations, rebates, solar incentives and the like. Kind of finishing up on this, I think you can see it's easy. I think you can understand these can be very challenging to implement. They reduce revenue. And they're reducing revenue at a time that people are using less of our products. The challenge, and what I think we are doing successfully, is as we do them right, as we do them over time, they provide the ability for us to reduce peak demands and avoid building capacity for those what would have otherwise been peak demands. I want to thank you for being here. I've been blessed to be here several times in the past. I think the Florida Water Forum has been a strong venue for discussing sustainability needs. We serve a diverse group of customers, including many of you in the room, manufacturing, industrial, and defense in the state. We're one of the largest port communities, and we appreciate the opportunity to show some of our own initiatives and be part of the sustainability discussion.
Thank you, Paul. So as I ask Herschel to see if there are any question cards, I'm interested in finding out, is there anyone in the room that has not toured a wastewater treatment plant? By a show of hands, who has not toured a wastewater treatment plant? Don't be shy. You have all seen, excellent, okay. It's one of my favorite things in the whole world. Like my whole face lit up, Paul, as you were talking about that. Okay, thank you for your questions. We do have a couple of questions. It's so good to be in a room that shares that passion. Tom Lang, thank you. Chip or Paul, has OUC looked into salinity grade? What, you want to stand and ask the question? Yeah, please, please, please.
Have you looked into the application of salinity gradient solar ponds, specifically like in the areas of Polk County where they've got the phosphate tailing to produce, obviously, electricity from ORC? We're doing this in Texas and got a huge resource there. Plus, it also produces fresh water, uses the heat in these ponds, and can produce hundreds of megawatts just in Polk County area.
No, we haven't. And in part, different chemistry in some of the water, which is what helps a piece of that. And secondly, we're actually looking at pond storage for floating solar panels right now as another alternative. This is how many times can we actually put this out there in a way that goes right into a transformer so that we're picking the location for where the solar goes in so it can be the most efficiently used. The rooftop solar is a great thing for people to do, as an example. But the most effective is the utility scale, and we're actually looking at many of the lakes that are retention ponds for highways, retention ponds for industrial sites, and is there a way to, because of we don't have a stratified system like you're talking about there.
Right, well that's what we're doing on the berms of these ponds, putting solar panels, and then the heat from the salinity gradient to produce ORC energy type of grid. It's just a thought.
Paul? Do you want to comment on that?
No, I'll just confess I'm not familiar with your technology, so I'll talk to you at the break. Look forward to hearing about it.
Great, okay. And Herschel, keep me straight on time. I don't have a watch here. So, Rick, how will the proliferation of solar and other distributed energy sources affect the economic viability of continuing to use coal and other solid fuel units?
Great question. A part of what we're seeing in the models that are going into it's either going to be called DG, distributed generation, or DER, distributed energy resources, the two terms that are being used. They're typically not going to be at the capacity to meet the peaks that the users are going to put in. It's too expensive. Additionally, you're still connected into our system. So as Paul was describing the need to be able to spread the current base load you have out, Baseload doesn't go away in any of these discussions. So it's just how do we continue to use the baseload we have to further meet all the other demands. And I'll confess to you that we're not looking at distributed generation as a competitive issue. We want to be able to put it in there better than you can, because we're dealing with it in a means that is at a utility scale. And we're looking at ways that we can do it where we can provide longer term maintenance and viability of these systems, because we do think they are the way the future is going to happen.
And I'll add to that, I don't think it's one or the other. I think it's all the above. We're going to need all those types of sources as we move forward.
Okay. Let me ask you one last question on policy, because you both touched on it. And since you do have a room of experts here and stakeholders together, federal policy may or may not be imposed on you as it relates to issues that impact both of your industries, right? Water and energy. What do you do to preserve what you both mentioned as the opportunity for the states to implement the correct policy that doesn't negatively impact your business, addresses growth and demand, and benefits the consumer? That's the last question, and I want both of you to have the opportunity to answer it.
And Lila, I think it's an interesting question, but because of the way, and I'm going to try and fit the answer in as succinctly as I can, but the way the federal policy is being passed down, that it will be implemented through the states, but the federal government still holds all the rights to say no in the process. It's how brave will the state be when it comes to writing the state implementation plans going out and beyond the 2030 requirement that we have in this deadline. It's artificially imposed. Coming to the industry and saying, and this could be a way the state could approach this, is we will comply with your carbon reduction plan. We will meet your goals. Give us a chance to use the technology and the knowledge we have and time to do this in a way that we amortize our assets, the newest, best technology is put in place, and it's done in a reliable way to meet all the other federal requirements out there, including clean water, the Federal Energy Regulatory Commission, and on and on. So it's, that would be my response.
And rounding that out, we work with other agencies like AIF. I think AIF has been a great example of that. They were a tremendous partner on numeric nutrient criteria, on exactly what you're talking about, is helping to influence some really probably well-intentioned but bad effects from overreaching federal regulation. We are really blessed in this state to have such well-staffed and competent regulatory agencies as we have. And you can work with them. You certainly don't win everything, but you can work with them to bring more common sense regulation in the state many times than you can with the feds. At the federal level, I think we all have to work together through our associations to move the needle where we can.
Okay. Join me in thanking Paul and Chip, please. Thank you.